Hi, Professor.
Are you?
I'm the first one here.
Can see.
But
And
today's the last day.
I know you're excited, right or wrong?
I'm not excited, but like if I get a good grade in this class, I'll be excited.
Oh, it's all yours. It's all on you. You work hard, and
Yeah, my other
eh,
class, I didn't expect what grade I got.
how
I
many
had a
classes?
B.
How many classes are you taking this semester?
Hmm?
How many classes are you
Oh, I
taking this
took
semester?
what's it called? English 101 as well, and then
And this one.
so like she was very rude and I'm not even gonna lie, I hated her. So like she gave me an 86 or something, right, on Canvas. And then she was like, "Oh, check Panther Portal." And I checked Panther, it's an A. And I'm like, "How I get an A?" I was so
Maybe there are other assignment. When students look at the grade, they don't know that at the end of the semester, the professor
Mhm.
have to put together all the grades, and
Right,
then each assignment have a weight. So
right, right.
you might have a B or
Uh-huh.
85 in one assignment, but if that assignment have a big weight,
Right, right, right.
you can push up your grade to a yeah. It's
Right.
possible.
And she also did like some extra credit or something. I did not expect it. I was so happy. I was like, ah, I have a 4.0 GPA right now because I just started college. So if I don't get an A in this class, I'm gonna be very
Ah,
sad.
not my fault. Not my fault.
Yes, it is your fault, Professor. You're the one grading.
No, I just give you what you get.
Right, I got you. I got you. So yeah. Yesterday I was trying to do the test and like I go back, I'm like, let me retake it because I was trying to study at first.
Yeah.
um and I like some of the question I didn't get, so I was like, you know what, let me just study this and then let me retake it because the retake's available. I try to retake it, there's no retake button. I'm like, oh my god. I had to email him. So yeah.
Remind me at the end. I will put it back so that you
Okay.
and other people who want to retake it can also retake it. But this will be the final retake. No more. I'm going to be mean now.
Okay, okay, okay. I know. I mean, I don't. There should be no other excuses. Like, just do your work. If I have any questions, I'll email you. I was gonna ask if I could get like your number, so like easy access. So if you don't check email
But
in the
I
right
thought I
time,
thought I emailed it to you.
really, I don't. I don't.
Probably there was the last time you asked for it. I told you I will email you.
No, I didn't get an email.
Then after I will email it again.
Okay, I
I
would
think
appreciate that because, just in case, and like we don't have any more classes, so if I can't really speak to you like face to face, so
like
thank
others have
you.
joined today
Yeah.
again. Maybe some are having problem with the. I think probably they are trying to finish their other homework. Probably. Yeah. All
Yeah.
right, we can start now. Um, Today we round up. I'm sure all of you. I don't know about Miss Bista, but I'm sure all of you are excited. Yeah. Now, the, uh, this topic will be using Excel, so it will be faster than others. If you want to use the formula for it, it will take us a lot. We may not even finish it today. So, but with Excel, that's the beauty of Excel, and it's even good so that in the office you'll be doing, let's say you're going to do some forecast. You'll be using Excel, so using it now make you familiar to it, and that means that you can use it to do anything, any kind of forecast. And like I explained yesterday, we'll be working on correlation and regression. And correlation is simply means a statistical way to measure how the extent where how two variables move together, two or more variables actually, but we'll be focused on only two variables, x and y. Where x can be any variable, which is the independent variable, we call it, and the y is the dependent variable. Now, regression tells us the strength of that association in a way between the two variables. Now, here are some questions we answer with this correlation and regression. I think I mentioned this yesterday. does advertisements increase sales volume? Yes, we know it does. Otherwise, companies will not be spending millions or billions of dollars every year on advertisements. But to what extent? And are all advertising methods, are they equal? Like if you're using the online social media advertising and the traditional TV advertising, which of them is more powerful in terms of boosting sales? You know, does the a person's blood pressure, does it have any effect? You know, on the does a person's age and blood pressure, are they related? You know that they're related, but to what extent? So and so on and so forth. Now, two variables we're looking at in correlation and regression. One is called a dependent variable. These are the variable that we can control, that we cannot control. It's also called the Y variable. For example, when we say that advertisement and sales, so sales depend on advertisements to a large extent. So sales is the dependent variable. But the independent variable is the one we can control. We can control the amount of money we spend on advertisements, but we cannot control the amount of sale that will come from that advertising expenditure. So you can see the one we can control is the Y variable, which is the advertisement expenses, which is the independent variable or the X variable. But the one we cannot control is the dependent variable, the Y variable. This is why we define the independent variable as those variables that can be controlled or manipulated. Things like advertisement expenses, exercise, dieting, hours of study, and so on and so forth. So, for example, again, we can determine how long we exercise each day, but we cannot really have direct determination of how much of the amount of good health we can enjoy from that exercise that we do, you know, and so on and so forth. I mean, you can control your grades to a large extent by studying hard, studying everything we covered. But there are some people that study so hard, they will study so hard late in the night that they wake up so late. So by the time they come for the exam hall, the exam is always finished. That means even though they study so hard, they still fail the exam. You see what I mean? Things like that can happen. But generally speaking, you know that the hours of study have effect on the grades. Now, how do we measure this relationship? We use what is called correlation coefficients. So we use this symbol for the population correlation coefficients. See, rho, call it rho. But for the rho, except if we are doing census, we can't really determine it. So we use the sample, that's called R, sample correlation coefficients. Even though we have different types of correlation coefficients, the one that we interest us, go ahead. Yep. Any question? Any question? Okay, good. But you guys can see my screen, right?
Yes, we can, Professor.
All right. Now, there are many types, but one we are interested in is the one that is called the Pearson product moment correlation coefficient, which named after the mathematician that derived did a lot of work on it, Carl Pearson. So, and we use R to represent that. Now, we look at the range of values when doing this kind of computation. What are the range of values of R? It ranges from -1 to +1. It normally goes this way. Let's say, can you mute yourself on the background? Have this line. So on the left, it's very close to the edge of this. So let me bring it down a little bit. Range of value. Please mute yourself, Vanessa. Vanessa, can you mute yourself? So I'm gonna move it up a little bit. Okay, now it goes from -1 to the new trap, which is 0, and then to +1. So as we approach any of this, any of the ones, it becomes stronger. It can be stronger on the negative side or stronger on the positive side. So here indicates strong, negative. Is Vanessa, you there? Is Vanessa, are you there? I think she's Miss Vanessa, are you there? I think we lost him. Linear relationship. I'm gonna move it down a little bit so I can have more room. Okay. Linear relationship. Yeah. All right. Okay. Now, 0 means no relationship at all. No linear relationship between the two variables. They are not related in any way. Relationship. And +1 indicates a strong positive linear relationship. I will explain what these things are in a few minutes. So as we approach any of the +1 or -1, it becomes stronger. Strong, positive, okay, linear relationship. Linear relationship. Linear between the two variables relationship. Yeah.
Can you click like ignore when you click on the red? There should be something that says ignore. Ignore once.
So which means that a value of, let's say, a value of -0.75, which can be 0.25, is negative side. Okay, is not as strong as -0.85 or 87 or 88 even. See, this one is stronger. Or I can even say from on the positive side, let's say 0.40 is not as strong as 0.75 or 75 or 76. You know, as they approach the number, the ones on both sides, they get stronger. You know. Vanessa, can you mute yourself, please?
I thought I was muted.
You have like 2 accounts.
Vanessa, you have 2
that's
accounts.
why it's echoing.
Okay, good. Now, let me show you what I mean by all this. So the stronger, the closer they get to the -1 or to +1, they get stronger. But as they approach 0, they get weaker. Let me give you some example. With the I'll say, okay, you something like study habit and grade. The more hours you spend studying, the higher their grades. That should be very close to 0.75 or higher in terms of the R value. But how about this? The less hour you studied, the less the poorer will be a grade, unless you're a genius. But the truth is that genius is actually 90% hard work and 10% natural ability, probably. So even if you're a genius, you still have to work hard. Now, how about this? Speed and time of arrival. The higher the speed, the lesser the time, assuming that you don't crash the car. Which explain why, if you use a plane to go from here to Florida, you can get there in a matter of let's say 4 hours. But because plane moves very fast. But if you go by a car, might take you up to 2 days. Now that means so the higher this, when one variable increases and the other one decreases, that gives us a negative relationship. But when one variable increases and the other one also increases, it gives us a positive relationship. This relationship can also be represented using what they call the scatter plots or scatter diagrams. Now, a scatter diagram simply means the visual way of describing the nature of the relationship between the dependent variable y and the independent variable x. I will show you in a minute. So suppose our diagram gives us something like this. We have a y variable, and then of course 0 on this side. Then you have your s variable. Yeah, s variable. Okay, one is have 0. Let's say we have 1. Okay, 2, 3. Doesn't matter whether it's any number at all can be there. 4. I can even make it 10, 5, 10. You don't have to. We don't have to put it now. I can make 5, 10. Okay. Because it can be large numbers. Okay. 15. 20, whatever it is. And then, okay. This is SY, this is for X. So that we have our line in this form. Okay. And then we plot the different values of S and Y. Okay, and we're getting, okay, this is your X right here. Okay, so S variable. So suppose we plot our values for S and Y, and we're getting stuff like this, scattered. Okay. The data points like this. Okay. Okay. You can see it's going up like a trending high. Sometimes they might even scatter a little bit. Okay. Now you can see that it is trending up like this. This indicates this indicates a strong positive, okay, linear relationship between, Okay. X and Y. Between X and Y. X and Y. You know how you do this in your algebra class where you have the X and Y variable. That means when S increases, Y increases. A good example is more advertisements, more sales. More hours of study, better grades. So as one variable increases, the other one increases. You can see the increasing trend this way. Now, we can also draw the scatter plots that shows the opposite. Where we have X, the Y variable, dependent variable, and also the independent variable X. Okay, X. You can put your diagram for Y, okay, then and X. In this case, you can have something like this. After you plot the charts, yeah, and then it keeps trending down. Okay. 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 All right. They might even have one on this side. It went out of the line to somewhere else. But bottom line is that everything is trending down. Okay. And then you can see that it's going down. See, trending down. So this indicates a strong negative
Linear relationship.
That linear relationship between S and Y. Relationship. Yeah. Between X and Y. Now, sometimes there may be no relationship at all, which we can find to be in this form. I got the Y-axis, and then the X-axis. Okay. Now, and you can have your number, the value as this form. The graph, for your S axis and Y axis for your algebra class, that if you remember. So the S can be anywhere it wants to be, scattered. It has no pattern at all. Okay. It's all over the place. So this indicates no linear relationship between S and Y. Okay, excuse me. Between X and Y. Unlike this one where we have negative pattern trending down. For example, the higher the speed, the lesser the time. And sometimes there are some part-time jobs are like that, like some warehouse job. If you're not full-time, if there's a shipment that needs to be packaged, like those warehouses that will do mainly packaging. If the workers work so fast, they finish the job within a week, and the following week there will be no job. So if higher the speed, less job to do, or driving, the higher the speed, the lesser the arrival time. But this one, there's no pattern. So you can say that you can Say, how about this? Somebody, the rate of co-production of oil in Saudi Arabia compared to the employment rate in America. They're not correlated at all. They're not related. So there's no relationship. Now, so this is what we call scatter diagram. Well, the good news is that we'll be using Excel to draw it today, so we don't have to go through all these steps. Okay. Any question before we continue? Yeah. No question. Good. So as we do correlation and regression, we are trying to estimate the value of R here, the sample corrosion coefficient R. See R, and also we might even try to, of course, naturally we try to estimate the R square, which explains how much of the variability in factor X and Y that is caused by X. Another thing we try to estimate is also the regression equation, which measure the extent we can predict one variable with another. Usually it is written in this form: Y equals to B0 plus B1X. B0 is this Y-intercept. B0 here, B0 is the Y-intercept. You can remember this from your algebra class. That's B0, Y-intercept. And B1 is the slope. Of course, you know that the slope is the rate of change, the slope. So once we get that, we can predict Y using any value of X that you are given. Then, of course, you can test hypothesis with it too. You can test hypothesis with regression. And before we can do all this, we have to compute all these values. Sum of square for X, sum of square for Y, sum of square for X and Y interaction, and of course the slope, then the Y-intercept, and then we can plug it into the this formula to get our correlation coefficient. All these things take a long process of calculations. So, but since we're using Excel, we know we'll be worried about it today. Let's see how this works. Says a random sample of N9 steers. It says the live weight and dressed weight we are recorded. It says in the table below, we let Y denote the dressed weight, and then S denote the corresponding live weight. You know, the dressed weight, after they are put them in packages in the stores, call it dressed weight. Live weight is the weight it has before they do the boning, removing the bones, and of course the outer skin, and then packaging it. That's the live weight. So does live weight depend on dress weight? So he said to use this sample to obtain at least the least square estimate of the regression equation. That is, find the regression equation for this. So I can estimate the right life. Let me make it part A, part B. Find that part. I'll make part A to B, draw a scatter plot to represent this data. So A says construct a scatter plot. Construct a scatter plot to represent this data. Okay, and part B then says use the sample data to obtain the least square estimate of the regression equation. Okay. Now, to do this, it's a simple process. We put all this in Excel. So let's do it. You ready? Are you all ready?
Yeah.
We're ready.
Very good. So I'm gonna copy all this. Well, I want to copy all this. copy this. I'm going to your Excel. I'm gonna open Excel. I'm trying to figure out the best way, because there are many ways you can do this in Excel. Okay, I'm pasting in Excel. Live weight and rest weight. So live weight is the X and rest weight is the Y. Okay. Okay. I mean, live weight is the X. So live weight. Then rest weight.
Hello, sir. Yeah, sorry to cut you short. The last time I tried to copy and paste just the way you did, mine did not go down like this. Vertical.
Are you copying it from Word?
Yes.
And it didn't work out?
No, it went straight vertical. Straight. It did not go the way yours did. Mine just went the other way.
So are you saying I'm doing magic? Is that what you're trying to say, Miss Dolly, right?
Yes, sir.
I didn't do any magic. Maybe, first of all, let me see. Even mine doesn't go well that well, but I'm gonna repaste it here. Okay. So maybe it depends. It depends on the kind of version of Excel that you're using. It should go well.
I wanted to like say something because I tried it too. It was the data where it was like separate numbers, like 1, 2, 3, 4, from like the project, and I tried to paste it into the Excel. It went all straight and didn't go up to didn't go down.
Yeah, exactly. That's
so you joined her in accusing me of doing a voodoo, right?
But like I think it's the difference because yours is like more of a table. The one I tried to paste was like a scattered number. Yeah.
Oh, in that case, if it doesn't want to go that with them, type it manually.
Yeah, type it down.
Type it manually. I don't know why it does that. You know, those in IT can answer that better than me. But I just, but sometimes it works for me. Sometimes it doesn't work for me. Like you can see, this one doesn't work completely, so I have to replace it.
You just have lucky hands.
Then there she go again. My hand is just regular hand. Okay.
Okay, if you say so.
All right, now let us draw the graph. So we can just highlight it. Okay. For the scatter plot, this is part A. So we can just draw the scatter plot from here. Since it's scatter plot, we don't have to worry about this one. I hope you can give us what we want. Let me see, live weight and rest weight. Let me copy everything and then put it here. And then see this one, the chart. See, it will tell, once you put your cursor, it will come out and say insert scatter X and Y or bubble chart. Click on that and choose this one. Oops, not this one. Okay. You see what this thing can do? All right, let's see. Let me see the best way to do this. This and get scatter plot.
Where did that come from?
Huh?
Would you inserted that and wait a minute? I'm trying to follow. You be going too fast.
Okay, what's the question? What do you want to ask?
I'm trying to paste it into Excel. It ain't even going.
Oh, in that case, type it manually.
You gotta type it.
Yeah, type it in manually. If it doesn't allow you to paste it.
Okay.
So now this is let me see if this one works. Okay. I'll find out which one works. Okay. It's not giving me what I want. So what's the best way to do it? In that case, I'll just go straight to data. So I'm gonna go to data, okay, data analysis, so that it can bring us, we go through to the regression. Now, when you come up, look for regression. It's right here. You can see the regression, then click OK. For the Y range, which is the dress weight, click here and then copy from here dress weight. Okay. For the X range, which is the live weight, click here and put the live weight. Okay. Now, because we included their names, the title when we are highlighting it, so we're gonna check labels. Do we need confidence level? I don't think we do. Now, the output range, that is where we want it to place the charts. You can click and let's say paste it here. Not bad. Then you include other things that you want to put there. Residuals, standard residual, then line of fit. That should be enough. Then click OK. To give you everything, let me see, it should be plotting the graph. Let me see, let me move this into that side. Okay, and then move it. You know what? I'm gonna move it this way. Okay. Yeah, if you plot something for us. Yeah, see the graph. It's right here. See? They are so close. You know why you do it like this way? The numbers are so close. You look at this here. That's why the other graph couldn't give us, because they are so close from 4 to 3. The highest we have there is 4.6. Sorry, 4.8. Lowest is 3.4. But these one are all 2s, 2 point this, 2 point that, you know. That's why the other graph couldn't give us it clearly. But this one definitely give us what it looks like. The yellow ones are the live weight, and the blue ones are the dry weight. If I remove this, it will be more, you know, big. Now, the good thing about this is that if you look at the question, that question asked us to draw the scatter plot. We have it now, and use it to get the regression equation. So our regression equation, I'm going to put it here in the chart. The good thing is that once we have the chart drawn, we can get it from there. How? So look, if you go here, click on this plus sign, you can see where there's a trend line. If you click on the trend line, the predicted dress weight, you can use that one, okay, and then or you just the dress weight. Then click OK. See, it add a trend line. See, now you can then add the equation on the line. I think, yep. For the forecast, linear. Okay, let's say, let me remove this linear. More options, so we can give us more things to put there. Let me try it again. Now, legends. Normally, it will ask you, do you want to put equation on the line? Okay, no, this. The trend line, I click on it. Okay, it didn't tell us, it didn't ask us that question. No. Okay, now, irrespective of that, we can still get our regression equation from the other outputs. Okay, So, but at least you have seen the scatter plot here. So this shows us there's see it is trending up, which indicates that there's a positive relationship, a positive relationship between the live weight and the dressed weight. Now, to get the regression equation, equation line, let me see. You can get it from here. Let me move this away. You can see the coefficients. Where we have the coefficients. This one here is your slope. This is your slope right there. Sorry, the y-intercept right there. This is y-intercept right there. And this one here is your slope. Okay, I'm gonna use blue for that, so that the line becomes equals. Let me insert a text box on here. Okay, I'm gonna use text box to put it here. Okay, I'm gonna put it here. It becomes y equals the intercept is 0.08604 all the way down. So stop at the third decimal place. 0.086, 0.086. Okay. The slope, which is the live weight. So sorry, not the rate of increase in live weight is 0.61662. So just plus 0.616 x. So let me write it down so that we can copy it, put it on the in the Word document. Y equals 0.086 plus 0.616x. That's the slope. Now, so we have gotten our scatter plot. So I'm going to copy it. This will give you an idea of how to paste your work in your project. I'm going to copy this and then go to Word and paste it. Okay. Where we're supposed to answer the question here. So for this, I'm going to paste it here. Control V. Okay. You paste it right there. See, it's there now. Now, so if you say construct a scatter plot, this is our scatter plot right there. Then it says write the equation of the regression line. We have found it from the output. So the regression equation is the.
I'm sorry, Professor, but we
Yes,
only still see your Excel.
Yes, okay.
Screen.
You don't see my Word?
No, right now
No.
we're just looking at Excel.
Yeah, okay, let me go back then. Let me go back to Excel. You can see the Excel now, right?
Yeah.
Yes.
So I'm gonna move this here. So I just like I was trying to explain the way I'm doing it now. It can be give you an idea of how to copy and when you do your work in Excel in your project, you can copy it and paste it on the Word or the project before you submit. You click on it, see where I see at the last line. You click on this line, then Control C as a copy. Then you go to your Word document where you want to paste it. I've already pasted it before, but I'm going to remove this and paste it again. Control V. Can you see this one?
Yeah.
Yeah.
So,
Yeah.
so it's there now. So that's how you paste it from Word to the Excel. Now for the so use the sample data to obtain the least square estimate of the regression equation. So our regression equation is here. We already have it there in Excel as you get it from this one of this output here from the graph we drew, and that is right here. Y equals to 0.086 plus 0.616x. These are all the weights. So it's gonna be I'm going to go and type it in. Okay. y equals 0.086 plus 0.616x. Okay, what does this mean? It means that the dress weight varies. Remember, this is about dress weight and life weight. The dress weight varies. The dress weight weight. Now, because it's a plus sign, that means it increases at a rate of, I would say, 0.616. These are in pounds. These are in hundreds of pounds. So 0.016, we multiply by 100, that means 61.6 pounds, 61.6 pounds. Sorry, my mistake. By 0.616, 0.616 pounds. Okay. For each 1 pound increase in life weight. So dress weight increases by at the rate of 0.616 pounds. When the life weight increases, each time the life weight increases by 1 pound. That's what it means. Questions? Any question?
No.
No questions.
Right. So this one is you're having fun on this one, right? I think you're having fun on this one because it doesn't have to, I said to do most of the work. Am I right?
Yeah.
Let's do the one that involves more work. Like here, this is the table below shows the mileage and prices in thousands of 8 cars in the month. All these are in thousands. I just removed the zeros to make it simple. This, for example, 21.8 means 21,800. 16 means $16,000. So this one means 21,800 miles. So it says mileage, and these are the mileage and these are the price. Say construct a scatter plot for the data, calculate the correlation coefficient R, compute the value of R squared. R squared means the coefficient of determination, and then explain your results. Find the regression equation. Then what will be the predicted value of for a car with a 45,000 miles? That means here you're gonna put X equals to 45. Then is there a relationship between the mileage and the car price? Use alpha 0.05. Somebody can you mute yourself, please? So you got this mileage and car and price. So I'm gonna start with price mileage. I'm gonna copy this and paste it in Excel. Mileage and price. I'm gonna go down here. I think something is blocking it from here. Yeah. Okay, good. So I'm gonna go mileage. So I'm gonna start a new workbook. See, and put it right there. Okay. This is the mileage and price of the car. Yeah. Now I can say, okay, data analysis. Okay, regression. I'm going to choose regression right here. See regression. Then okay. Now for this mileage, so I'm going to for the Y input. I'm going to click this and put all the Y inputs right here. Okay. Then for the S range, I'm going to click here and put all the prices. Then I have okay, I'll check labels since I highlighted mileage and price. That's when I was doing this. For the output range, okay, I'm gonna put it right here. Then I need my residual standard errors and of course line of fit plot because they asked us to plot the scatter plot. So I then click OK to give me all the results at once. So I'm gonna move this to that side. So you can see that it gave me this scatter plot right away. See, mileage and this. And I say price and mileage are already the line of this is the scatter plot. Okay. Now I'm gonna copy this, Control C, and go to Word where I'm answering the question. So the first one is construct the scatter plot. So I'm gonna write this here. Solution. Okay. Here's the scatter plot right here. Control V goes in. The scatter plot indicates a negative relationship. You can see that it's trending down, which means that as the mileage increases, I actually drew it the wrong way. Mileage should be my X variable here. So I'm gonna redraw this. I'm gonna redraw this because it's not good. So let me redo it. I'm gonna redo it. It's not good. Mileage should be the X variable, not the Y variable. So
you're saying the graph is backwards or
yeah,
upside down?
Yeah, I clicked the wrong thing. Don't worry, we'll fix it. Let me start from this place.
So how would we know if we did it backwards?
So instead of clicking the mileage for X, I went and clicked the Y. See? I will show you what I mean. Don't worry. Instead of clicking for mileage, instead of clicking on the X, I clicked on the Y. That's why it had it backward. So let me show you again so you can see that. Mileage price it depends on the mileage. You know that for car sales, the higher your car mileage, the lower the price. Even though some antique cars break that rule. So you will see what happened here. This is the mileage here. Mileage. This is the price. So what happened was this. When I click on data analysis, right? And I choose Excel, so I choose a regression. Now, mileage is the X variable. Instead of clicking on the X, I click on the Y. See? That's why it happened. So see this Y range, which is the price. This is Y range, which is the price from here, price the Y. And for the X variable is the mileage. See, input X range. So I'm gonna click on that, put the X, okay, for the mileage. Everything have been checked. Check label, output. So the output, I want the output to be here, or even under it. I can put the output under it. Make it easy for us. Residuals are already checked. Line of plot are checked. And I can click OK. See, it will place under. So you can see that now it is more better arranged. You can see that the price is here now and the mileage is here. See, so you can see that. Let me copy it, Control C, and then go to Word. Okay, and paste it where it's supposed to be. Control V. So you can see the trend. So showing that as the mileage increases, the price decreases. So at the mileage of, let's say this is 0.25, see the price is high at $15,000. When the mileage reaches like almost 70,000 miles, it will decline to about 9 or 10,000. See, so you can show it. This indicated negative linear relationship between mileage and price. Questions?
No.
No.
No questions.
No.
Now, next one is the value of the correlation coefficient, R. So you can get that solution. You can get the value R solution. Now, Excel won't tell you whether it is negative or positive, but you know that from the scatter plot. So now let's see what we're gonna have here. It is right here. R. I see a multiple R. See R. This is multiple R. It's R here. So the R, this is the answer for 0.75788, which is 0.75, basically 0.76. Yeah, 0.76. So R is 0.76. So you got to be negative 0.76. The value R equals negative 0.76, because we know from the trend it is trending down, negative, so it's a negative relationship. So that's which indicates this indicates, because it is closer to -1. You can say that this indicates a strong negative linear relationship between mileage, which is X variable, and price, which is Y variable. So as the price increases, mileage increases, price decreases, and vice versa. Questions?
No.
With that Excel, this one will take you like 30 minutes or more to get this particular one alone. Excel made it easy. Next thing is to say compute the R square, right? Say compute R square. I mean square root of R square. Now, Excel again give us the value for R squared. It is right here. Otherwise, see R square right here. I see right there. Very clear. I see R square 0.574. R square is 0.574. R squared. So our R squared equals 0.574 from Excel, or I can call it 57.4%. So what does this mean? It means that mileage, okay, 1 minute. Excuse me. It means that this means that 57.4% of the increase in price is caused by the increase in mileage. Sorry, of the decrease in price, because this is negative. So if it's 7.4% of the decrease in price is caused by increase in mileage. This means that about 57.4%, 57.4% of the decrease in price of the car is caused by the increase in mileage. Question? Any query?
No.
No questions.
Excellent. So we're having fun then. I was right. I should have betted. I should have betted on that. That would be.
Oh,
I don't know about
fun.
fun, Professor, but
Right.
What's that?
Not sure if you would really call it fun.
Are you sure?
Positive.
Yep.
Absolutely
You can't
sure.
wait to get. You can't wait to get rid of me, right? Right or wrong? Nobody wants to say anything. No, don't be scared. All right, let's see. Let's see. Look at this one. It says find the regression equation. Now, this one you can find it in one of the charts, right? If you go to one of the charts, we have here. You can see we are under this one. You can see, yeah. If we did a test of hypothesis yesterday, you can remember the degree of freedom. If we are using ANOVA, this is our degree of freedom right here, but we're not worried about the ANOVA. So if you look at it here, you can see where they write the coefficients. This one is for B0. This one is for the B0 is the intercept. This one is for this slope. So our intercept is this, and our slope is this one here. So I'm going to use this for the slope. So now let me write them down, which means that our equation of the regression, our regression equation will be this. Okay. Okay, we have it in this form. Y equals, this one is at 17.1003. So that's a long one. So just 17.1 is good enough. 17.1. This one is negative 0.00902. That's a long one. Just minus 0.090. Let me make it a little bit larger so you can see it properly. Probably 16 should be good enough. So that's so you gotta put the x at the end of there because this is the slope x. So let me write it down. Y equals 17.1. Y equal to 17.1 minus 0.090x. So this means that let's go and write it on the other side. The other side of the equation on the Word document. So I'm gonna go there and write the equation of the regression line. So the regression equation is y equals 17.1 minus 0.090x. So again, this means that, remember, these are in thousands. In thousands. So this one is 21.8, which means 21,800. So if you multiply this by 1,000, this 0.090 by 1,000, it will give you $90, I believe. Yep. So this means that means that sorry, the slope of the slope of 0 negative what's that? Hello.
Hello, can you hear me?
What do you want to say?
Yeah, I said, where did you get the 0.090?
It's right here in the Excel. Let me show you. Where we have the coefficients. Let's see right here. Okay. Can you see it with blue?
Yes.
That's where you come from. That's 0.0902. So you write preferably 3 decimal places is good enough. So we have it right there. So this means that the slope of 0.090 means that the price of the car decrease over time at the rate of $90 Actually, $90. $90 for per 1,000 increase in mileage. Yeah, question?
No.
We're almost done. Solution, this is the solution for that. Now, let's this one said, predict what will be the predicted price for a car with 45,000 miles. Remember, this I removed the 1,000 from here. You can see I removed the 3 zeros from all these numbers. So for a car of 45,000 miles, to say what will be the price. So 45,000 just that means that X equals 45. So 45 represents 45,000 miles. Plug it into this regression equation and you get the price of the car in question. Okay, it means that since S is 45, that means equals 17.1 minus 0.090 times 45, plug in 45. And that will give you this amount. Let me write it down and then get it from the calculator. Y equals to 17.1 minus 0.090, plug in 45. So taking you to the calculator will give us the value we are talking about here. So 17.1 minus 0. Okay, we can have it here. 0.090 times 45. Okay, give me 13.05. Which means it is 13.05. 13.05. Which if you multiply by 1,000, because everything is 1,000 by 1,000, that means at $13,050. So a car that has a mileage of 45,000 miles will cost $13,050. Question? Okay, no question. Good.
No questions. No
Good,
questions.
very good. Then last example said, is there a relationship between mileage and car price? Use alpha 0.05. So to answer this solution, you state null hypothesis. Okay. It goes this way: HO and H1 and H1. So H really the slope. Let's say the slope estimate. This case is state beta beta 0 is not equal to beta 1, or you can say the other way around, that they are not, S and Y are not linearly related. You can even say, put it in a simple form: S and Y are not linearly related, or that S and Y are not. Yes, that would be this the null hypothesis. Then the alternative would be that S and Y are linearly related. So beta 0 equal B is not equal to 0. Yes. So let's put it this way. We can say rho. I think rho should be the best thing to. Rho is not equal to 0. I'll put it this way. Let's see if I can find rho. Okay. I'll look for the value of rho. It's gonna be somewhere. I'll find it somewhere here. I mean, maybe I'll use this. Perhaps I can use this. Maybe I should use that. Rho is not equal to 0. Rho is not equal to 0, and is equal to 0. I mean, X and Y. Of course, mileage. You can say mileage and price are not linearly related. Yeah. Then the alternative hypothesis would be that rho, okay, is not equal to 0. Okay. Put the wrong thing. It's not equal to 0. This one. That means mileage and price are linearly related. Now alpha, so use alpha 0.05. What is it again? Yeah, use alpha 0.05. Alpha is 0.05. That is the significance level.
So why'd you say 0?
Because 0 means that remember when I was writing about correlation coefficients, the range of values, I mentioned that here they approach 0. That means there's no
so if it doesn't have a relationship, it's 0, right? I got you.
Now, so with this equation, so now usually for regression coefficient, for the simple regression, we use two-tailed test because you have two variables. So S and Y, two different S and Y variables. So we usually do two-tailed test on it. Not all the case, but for the simple one, we usually use two-tailed test, non-linear related and linear related. Then from there we can now have our critical value or p-value. We can use p-value or we can use critical value. Excuse me. Suppose that we want to, if we want to use, I'll write both of them. The p-value that we have is this, equals, if you go to the Excel, excuse me, you will see the p-value given right there. For the slope, you can see the p-value right here, which is 0. Write it down. 0. Those of you who cannot see it, I'm going to highlight it so you can see it right here. See, right here, 0.0293 so 9.
So how do we know not to pick the intercept, to pick mileage?
But the intercept is just the intercept where the X crosses the Y. At that point, Y value is 0. S value is 0. So it doesn't. So you're talking about that's the mileage.
Right.
It depends on the price. So yeah.
I got you.
So the value is 0.0029. So 0.029 is good enough. And if you want to text, you use the critical value for. This is the F statistics. Say value critical. Sorry, T statistics. Can have it here for the slope negative 0. T. T will be negative 2.84. Okay. Now it's 2.84. Now you can test for the intercept too, as well, but for this particular problem, we are interested in the slope. That's why we are picking up mainly on the slope. There's some question we would like you to test for the intercept. That's why Excel also give you both the p-value and the test statistics for the intercept. So now let's have this put in. P-value is this. Let's take your p-value. Go back here. The p-value is 0.029. See? Now, you remember when we were doing a p-value method, when we were testing hypothesis, I mentioned the criteria to use for accepting, for rejecting or not rejecting the hypothesis if you're using the p-value method. The p-value says, if the p-value is less than or equal to alpha, reject no hypothesis. If the p-value is greater than alpha, do not reject hypothesis. So in this case, you look at the p-value, you can see that it is less than alpha. It's less than alpha. So alpha is 0.0. Let me bring it down because we're about to make our decision, final decision. Okay. Alpha is 0.05 and p-value is 0.029. So since reject is a reject, HO, since the p-value of 0.029 is less than the alpha is less than 0.05, it's less than 0.05. So the conclusion, so we are rejecting the null hypothesis. So that means we're accepting this one. So that means the mileage and price are linearly related. So conclusion becomes mileage and price are linearly related. Do you agree? Do you agree?
Sure.
We guess so. Well, look, I guess so.
Okay, that concludes our class. It has been a pleasure doing business with you guys.
You too, Professor.
So let me check your attendance. Oh, the final exam. Before I check, let me show you where the final exam will be. I'll put it in Canvas. So I'm gonna make it available because this is the final exam and the school wants you to take it on Monday. So I have to go by what the school said by making it available midnight Sunday. So you have all the Monday to take it. It will not be taken on Excel. It will be taken in Canvas. You work out. Let me show you where it is located. Click on assignment. And then once you click on assignment, you go down. You can see the screen, right?
Yeah.
Yes.
So this is where
Yeah.
the final exam will be. Let me move this so you can see.
I thought you said we're not taking the midterm exam.
No, there's no midterm. There's no midterm. I'm talking about the final exam. It's right here.
Oh, that one. I got you.
You click on it and they bring it up. I have not made it available yet. So once you click on it, it will take you to the, I don't know how you see it from your own side, but it will take you to this question where you can answer this question. It is 20 questions. You have 1 hour, 110 minutes, which is about almost 2 hours. Take it. And it's when you click on preview, it will bring you to where the questions are. And then you can start taking it. So you will solve it on paper and then put your answer in. I don't know if it will let me go on preview. They won't let me go on preview. So, but so once you click on preview, it will give you this dialog box to begin. You click on begin, and then you begin answering the questions. Now, when you work it on paper, what do you say?
Are you able to click begin to like show us?
No, yes, I can click it, but I can't click it now.
Okay.
I don't want you to see the questions before. Okay.
Oh, I got you.
Now, if you go back, so when you're solving it, write to work on paper. It doesn't matter whether you write it correct. Just whatever you do on paper when you're solving it, you can then upload it here. You can see where you say upload. So I'll make it available midnight Sunday. It will be due on Monday, that Monday by midnight when I make it available. Okay. And then for your project, this is where you submit it. Of course, you know that this is where you submit the projects. You can upload it here. Okay.
Is this a cumulative final, or is this just the last part that we've done since test 2?
The one I just showed you, that's the final exam. After that, no more exam from you. Did that answer your question?
I think she meant, can I, oh, go ahead.
I was gonna say, is it cumulative? Like, is it everything that we've gone over?
Yes, I picked one question from each section. Yes.
Oh God. Okay.
Oh, it's just like the other exam you take. It's just like this one is the final one. That's all.
Yeah, but the time is very low.
Exactly.
I can guarantee you're gonna breeze through this.
So is the regression included?
Well, if it is included, I have made it easy for you today, right? With the Excel.
Okay.
I remove all those formulas you need to that way, take all your time. Remember? So if the regression is included, that means you can count that one as the one that you already passed. Am I right?
Okay.
The time is over.
I'm gonna upload this video for you too.
So what we did today is that on the test? On the final exam?
A part of it will be on the test. My answer.
Oh my Lord.
Or the school actually prepared the exam, but it have every section. Just it's not something that bad. You will see. You see, it's just like any other quiz test you take, except that this time they have different sections on different topics we cover in the class.
And it's only 25%, right?
Yeah, it's 25%. It has weight. Yes, of course, it has weight. Yeah.
So if you does the uploading the work give you extra credit?
If you're already passing, if you have submitted everything and you're already passing, then you are passing already. This exam can just push you from a C to B or B to A. You know what I mean?
Yeah, that can have a big difference.
Because only one exam, and yet it is 25 points. I think you're gonna.
We don't know our grades. Did you post our grades?
Huh?
Did you post the grades?
I'll post almost all of them will be done this year by Sunday. I'm gonna work very hard this weekend. I'm gonna work very hard this weekend. You're making me work too much this weekend.
Oh, and you told me to remind you about the test, remember? The retake.
What's the test again? Test number?
2.
Test 2, okay. All right. Okay. So, Bista, I have your name. Mrs. Ford, I have your name.
Did you get my email, Professor?
When did we send it?
Oh, Lord. So you probably ain't getting one of the emails I sent you. Wait a minute. Let me tell you.
The one you sent, is it about the assignment, the package? I sent you the package, remember?
Right. And I sent it back.
How? Oh, you finished it, right?
Yeah.
So no problem. I will get everything you finish. I will grade everything, okay?
Okay. All right. I got you.
No problem.
All right, and my hair already short. By the time I get finished, I won't have mine's gonna look like yours.
You thought? I'll pray for you, okay?
You have to because I told you I lost my brother.
Yeah, sorry about that.
His fiance, when the computer went out yesterday, my niece called me. His fiance passed. My nephew he's 11. He don't have no parents. Both parents died like 2 weeks apart. Ain't that sad?
Yeah, that's very sad.
And I'm like, what in the world is this little boy going to do? I can't even fathom. My mom's still living, but my dad died. I was like 22. And, but I was grown and I still fell apart. So he's 11. I mean, I'm like, Lord, I know it's for a reason and a purpose because God don't make mistakes. But, when you're looking at a human aspect, it's really, really sad. And it kind of threw me for a loop. You know, so now I got to figure out where he gonna live and all this and that. Cause I'm the oldest. Cause that was one of my older brothers. Now I'm the oldest, so they looking at me to trying to figure out a way for him.
Keep trying your best.
I keep praying. That's all. I just keep praying, and I just take one day at a time.
That's how to do it. One day at a time.
You gotta think ahead too fast, then I probably be in the crazy house. Yeah. So I'd say that's 3 people in a year span that I lost. That was really close. Yeah, but I'm gone because I don't want to hold your class up no longer. But I wanted you to know that.
Thank you, and I appreciate that. And please don't give up. Huh? Keep trying your best.
I'm not. That's not in my genes to give up. You know, no matter what. And, but I thank all of y'all because I know y'all gonna pray for me.
Yes,
Absolutely.
You're good.
Absolutely.
All right, y'all have a good evening.
Thank you. You too.
All right, bye bye.
Nice meeting y'all.
Bye.
Same here.
So,
Yeah.
okay, we're done with you after like Monday evening, Monday night. Is that what you're telling me?
Yeah.
Yeah.
We need to get together so we can go out and eat and have a drink or something. Oh, Professor OG.
Okay.
God, leave me alone, okay?
Have a good one. Bye bye.
Bye.
Yeah, bye. Okay. Now, Dolly, I got your name. Dolly, you here, right?
Yes, I'm here.
Got your name. Miss Darby's here. Got Darby.
Yes, Darby's here. Did you get my message yesterday? I sent you an email.
I will check it before after. Or do you feel you want to tell me about it now, or?
Yeah, just that I missed the second half of class because my internet and electricity went out yesterday.
For attendance, right?
Right.
This is Debbie, right?
Darby, yes.
I'm actually present yesterday.
Okay, because I came in like at the end, and right when I was getting ready to say I'm here, you cut it off, so I wasn't sure if you got me or not.
I'm actually present yesterday.
Okay, thank you.
Vanessa is here.
Yes, and I'm going to send you an email this evening, so look for it.
Ooh, so many emails.
No problem. I will look for it.
I haven't notified them all semester.
I think they're missing me already. I'll check it. No problem.
Okay. Have a good weekend.
You too.
Bye-bye.
I have Miss Walker here. I have Taiji Kent.
Good night.
Good night. Who else do I have here? I have Beast already.
Yeah, so I just wanted to remind you again. And if you don't do it, I'm gonna email you.
Yeah, I'll do it now. As soon as I put in this attendance.
Of course. You have a great rest of your summer, okay? Okay, thank you so much. And don't forget the number.
I won't.
All right, bye.
I will not.
Thank you.
No problem. Okay, bye-bye.